Alrighty. Okay, good morning everybody. My name is Gill. I am an SC at the Checkpoint UK office. I specifically work in the channel team. And today I'm delighted and thrilled to host this Friday's webinar, Securing the Software-Defined Data Center. Let's begin with what is the Software-Defined Data Center? The Software-Defined Data Center is effectively when the infrastructure within our data center is virtualized and delivered as a service. And the control of this data center is entirely automated by software. This is the ideal architecture for private, hybrid, and public clouds. You can think of a software-defined data center encompassing many virtualization layers. You have your virtual network, your software containers like your virtual machines, your virtual network topology. In fact, when we look inside of a software-defined data center, there are a number of components that come about to make the software-defined data centers. We won't go through the exhaustive list of what these components are, but rather we'll tackle a few of these components just so that we're on a broad page understanding of what a software-defined data center is. Some of these components include computer or server virtualization. This is effectively our virtual machines or virtual servers. You'll find that within this presentation, I use virtual machines and virtual servers interchangeably, but effectively this is one and the same, computer server virtualization. The second component within a software-defined data center is a software-defined networking controller, commonly abbreviated as an SDN controller. The purpose of a software-defined networking controller is network virtualization. And this brings about really cool and funky things we can do within our data centers. For example, if we have an SDN controller in London and an SDN controller in the US of A, if we have a virtual machine behind each of these SDN controllers, the SDN controllers are clever enough to intercept a packet and package it in a way so that when it finally reaches the destination in the US of A, the SDN controller there recognize that the packet's been manipulated and can repackage that packet towards the final destination of the virtual machine so that effectively both virtual machines look like they appear to be locally connected, i.e. connected on the same subnet. This negates the need for complex routing across our layer 3 infrastructure, our switches, our routers, our existing gateways, or the need for a VPN. So it effectively creates things like a layer 2 over a layer 3 network. And that's just one of the functions that a software-defined networking controller can bring to the table. There are huge and many functions and benefits that an SDN controller provides, but this is one of the main examples. Again, it's a little bit beyond the scope for this presentation to talk about the in-depth of a software-defined data center, as that is a subject in its own right worthy of several webinars and currently exists in several white papers. Another component we can find within the software-defined data center is software-defined storages, SDS. So imagine you have a virtual machine, you spin this up. SDS can provision a capacity of storage with its own set of SLAs around performance and durability. And then when you burn down that virtual machine, that capacity is restored back, ready to be provisioned for the next virtual machine wanting that storage. Again, very funky things we can do, all controlled by software. Then we have the management and automation software. This effectively enables an administrator to provision, control, and manage all software-defined data center components programmatically via CLI or API. The beauty of a software-defined data center is that we don't need to rely on the intelligence of hardware. Think of an SDN controller. All of that routing and networking information that we program within our switches, our firewalls, our routers, all of that intelligence can now live within the software, within the virtualization abstract. And this allows us to then rapidly provision a data center around applications in an automated, orchestrated fashion. In fact, software-defined data center is the way forward and delivers the much-needed agility and efficiency. If we compare and contrast that to our traditional approach, hardware-defined data centers, we can see straight away from the bat that innovation, as one of the key indicators of what we require from our infrastructure, tends to happen a lot quicker within the software-defined data center. Think about that for a moment. There are leaps of innovations in software almost all the time, weekly, monthly, if not quarterly basis, whereas the leap in hardware tends to be 3 to 5 years, tends to be in slow cycles. The second benefit of the software-defined data center is flexibility. Because we rely on software, we now have ample choice of infrastructure because the intelligence is in the software rather than the hardware. Whereas with the hardware-defined data center approach, we are usually locked into a particular vendor or choice of vendors. This could be because some of the intelligence we're utilizing within the hardware is proprietary, i.e. using a proprietary protocol only specific to a vendor, and therefore we are more locked into that vendor and less flexibility. The third key point is ease of insertion and deployment. This is key. If we were to provision a new service, for example, let's say we need to provision video conferencing. Within our hardware-defined data center, this might require vast configurations of our network. And in some extreme cases, because video streaming as a service is highly demanding, we may even have to do a forklift upgrade of our infrastructure to accommodate the service. However, with software-defined data center, the ease of insertion and deployment is high. It's non-disruptive. In fact, because everything is automated by software, the service can be provisioned by the data center rather than the other way around. So you can see that data centers are rapidly evolving. We've gone from static data centers with physical gateways, physical servers, physical switches, to a virtual data center where the server compute is virtualized. However, in that instance, network operations are still manual. Think about that for a moment. If we spin up a new virtual machine, we still have to give it an IP address. We still have to give it routing information. We then have to update the gateways, the firewall policies to encompass this new object that appears within our network. So again, that's very much a manual human intervention operation. With software-defined data center, networks are now also virtualized. Services can be dynamically inserted and orchestrated via automation. So in that same example, we spin up a new virtual machine. This becomes the new web server in an existing web server farm, and the IP address and its security profiles already captured and automated and provisioned in an orchestrated and automated way. Sounds pretty cool, huh? So what you end up with a software-defined data center, once fully realized and enabled, is something similar to the above. You have your critical infrastructure, server, storage, networking, convergence of it all integrated in a virtualization layer. You then have the automation software as the engine that drives this forward to the needs of the organization. And as a foundation, you can start to provide rapidly and very quickly IT service ecosystems, which can then span out to form IT services, such as services you deliver for a private cloud or enterprise applications or even desktop virtualization. All of that is now possible with software-defined data center because effectively everything is controlled by software. We're no longer requiring that intelligence or that level of investment within the hardware. So hopefully up to this point, we have a good idea of what a software-defined data center is. Again, as I mentioned previously, software-defined data center is a huge topic in its own right, and it's impractical for me to go over every nuances of a software-defined data center in the 1 hour that I have with you. But hopefully that's more than enough to get everyone on the same page so that we can now understand what the challenges that come about from a software-defined data center and what we need to address those challenges. So like with anything new and old, there are security challenges that present itself in software-defined data centers. Broadly speaking, there are 4 challenges. The first is the increase of traffic inside the data center. As we start to highly populate our physical hosts with virtual machines and other virtual machines and groups of virtual machines, our email server, our web server, whatever it may be, it starts to become a noisy environment. You have virtual machines talking to other virtual machines in that same physical host. In fact, it's estimated that 80% of our data center traffic is this type of traffic, is the intra-virtual machine traffic. We call this east-to-west traffic or lateral traffic because this traffic doesn't traverse our perimeter gateway. We are blind to this traffic. That's a big percentage of our traffic that we're blind to. The second challenge naturally follows on from the first, lateral threats inside the data center. This is because we have a lack of security and control between virtual machines. We can't control them in the same way as if they were physical servers. With physical servers, we can implement VLANs, we can implement physical segmentation, networking, and so forth. We also know in the industry that threats can easily traverse VLANs, and that threats tend to attack low priority services and then move on to critical systems. Modern threats can spread laterally inside the data center, moving from one application to another. The best example I can give you here is if you take your favorite medieval movie, 9 times out of 10 in these medieval movies, you have a scene with a castle. And the castle is a great analogy, because with a castle, in order to get in or out of the castle, it requires the release and the bringing up of the drawbridge, okay? So as a group of malicious people wanting to get into the castle, they'll either have to find another route in, a back door, or they can masquerade themselves as legitimate traders, coming through the front door as the bridge is lowered, and in those classic scenes that we see in those movies, out comes the sword and a massive rampage where everything in its path, in that lateral movement, is just disseminated. Or the Trojan horse effect, as we already know of Helen Troy. Either way, it's a great analogy because that drawbridge, the raising and lowering of the drawbridge, is our north to southbound traffic. However, once we're inside, once the threat is inside, it can just move laterally across, much like in those scenes where they move laterally and just murder everything in sight. So can our malware. It can move laterally from one machine to another. The third challenge is ignores data center changes. In our day-to-day operations in the server team, we may spin up new virtual machines. We may then move virtual machines from one physical host to another. We may change the IP address of a virtual machine. We may have dormant virtual machines that wake up, maybe because they're configured behind a load balancer, and as that load balancer reaches a threshold, it requires a spin up of a new virtual machine to increase the capacity. Or it could be virtual machines that just move between different VLANs. Either way, there are a number of day-to-day operations our server teams do. And what impedes this is security. For example, if I create a new virtual machine in my web server farm, I then have to raise a ticket with the security guys and let them know, hey, I've got a new IP address, it's a web server farm, please add this into the policy, please let me know when it's completed. Again, this really impedes the business agility if you need to deliver things quickly. And that's just one example. In the day-to-day operations, there are a number of changes being made, and traditional static controls fail to secure dynamic networks and highly mobile applications. And that leads us to the fourth challenge: security inhibits data center agility. Again, in my previous example, if we have to wait for a virtual machine to be created and then added to the policy and then network configurations to be able to route information to, then this could have a marginal effect on the business when delivering a service, particularly if you're an end customer and you're in your shopping cart and you have a virtual machine with a number of cores and you're just ready to kind of spin that up and leverage content on there. However, you have to wait a significant amount of time for that all to be provisioned in the back end. And that's because security is getting in the way. But security is needed, right? So what is needed? We now know at this stage what a software-defined data center is. We now know what the challenges that come about with a software-defined data center from a security perspective. So what do we need to address it? Well, there's 3 key requirements that we need inside of a data center. First of all, and this is the most obvious, we need visibility into that 80% traffic that we're currently blind to. We need a security visibility, right? The second key requirement is automated security provisioning to keep pace with dynamic data center changes. So when a server guy does their day-to-day operations, they spin up a new virtual machine, the security system should already know, that there's a new virtual machine, what the IP address is, what its profile is, i.e. it's provisioned as a web server, and therefore it knows the security profile required for web servers, and then just poof, make that happen in real time in an automated fashion, not relying on human intervention. The third key requirement, and this naturally follows on from the first, is automated insertion and deployment of advanced threat prevention to protect inside the data center. Now that we can see the traffic, let's control that traffic and enforce that traffic by leveraging IPS, antivirus, antibot, and whatever technology is at our disposal to ensure we have a very highly secure posture within our data center. So those requirements seem quite obvious, but quite ambitious. So what can we do? Not to fear, Checkpoint has a solution that fulfills these requirements and addresses each of those challenges we discussed around the software-defined data center. Within Checkpoint solution, within our portfolio, we have the ability to leverage a perimeter gateway for our north to southbound traffic, and what's known as VSEC, or virtual security, to secure the east and westbound traffic. All of this ties nicely within a software-defined data center, which may have an SDN controller and cloud management platforms, so we can now provide this automation orchestration, and I'll show you how. So a quick summary, or rather a quick introduction. What does VSEC bring to the table? We know it addresses the challenges we've mentioned earlier on, but fundamentally, what does it bring to the table? Well, it's 100% software-based, and broadly speaking, there are three main components that VSEC brings to the table. The first is segmenting the data center. If you imagine a physical host or a physical cluster of hosts with hundreds, if not thousands of virtual machines, that's effectively a flat network, okay? What we can do is we can easily micro-segment those virtual machines in their respective groups and profiles. And again, we'll discuss how we'll do this in the presentation. And then with that, we can also leverage advanced threat prevention, our software blades like IPS, antibot, antivirus, sandblock, to maintain or retain a highly secure posture. The second component it brings to the table is automation of virtual network and security, so security orchestration between virtual machines. If a virtual machine changes for any reason, i.e. it's being pulled down into maintenance, the IP address has changed, it's no longer a web server, it's going to become a lab server, all of this changes will be automated through the security. And then, of course, security control for all our data center traffic within our software-defined data center. VSEC gives us the ability to provide a consistent security policy, a unified security policy under one single management system for both our north, south, east, and westbound traffic. So let's take a quick look on how we secure our software-defined data center with Checkpoint VSEC. First of all, we integrate the VSEC controller. Now, VSEC do have two components, the VSEC gateway and the VSEC controller, and we'll talk a bit more about that as we go on. But we integrate the VSEC controller with the SDN and cloud connectors. Now, in this example, we're going to use VMware. VMware is one of the SDN controllers available. Their implementation of an SDN controller is NSX, and of course, everybody knows what vCenter is. So we integrate the VSEC controller, which sits on the Smart Center Manager, into NSX and vCenter. With that integration, we then secure the north and southbound traffic with a software-defined data center aware perimeter appliance. As you already know, Checkpoint has a wide range of appliances suitable for any size of organization, from our small 600 appliance all the way up to our 61,000 chassis-based appliance. The third step is to deploy the VSEC gateway inside the private cloud fabric and define policy. The VSEC gateway lives inside of the hypervisor within our software-defined data center. Then, with that leveraged, with step 4, we steer the east to west traffic to the Checkpoint virtual security gateway. And finally, we orchestrate. We securely orchestrate and automate operations, examples being that I have already mentioned up until this point. Okay, so the VSEC gateway sits within the hypervisor, and with it, we can leverage the software blades we use today within our physical gateways. For example, firewall, we can leverage the IPS software blade, which helps organizations stop exploits of known vulnerability. So that's particularly useful when we're waiting on patching or remediating a system. Antivirus, to help organizations block malicious files that inadvertently been downloaded by users when they're web browsing or received via the email channel. Antibot, which prevents bot damage from infected devices. So bots, as you know, are very tricky to detect with antivirus, purely because they're very much an egg. They very much look like a small footprint, a legitimate bit of traffic. The danger really only comes about when a bot makes an attempt to connect to your command and control server, which is the bad guys on the internet, and once they do that, they then receive their payloads or their instructions to be what they need to be. So this could be a DDoS bot, this could be a banking Trojan bot, or it could even be instructions to proliferate the internal network, look for key files, and perform data exfiltration to the command and control server. With Antibot, we can detect this initialized communication with command and control and block it and sever its link, rendering the bot useless. Then we can alert the relevant teams that there is a bot on a machine. So a pretty useful software blade that really goes the mile in enabling our security posture. We also have Sandblast, which deals with unknown and zero-day malware. As we know, there are a number of unknown and zero-day malware in the wild. This is malware that currently do not have a signature or a profile or MD5 hash, and therefore existing technologies like IPS, antivirus, antibot, which relies on something known, fail. So with Sandblast, what we can do is if they do get past our first line of defense, we can then emulate those files within a virtual environment, which is called a virtual sandboxing technology. And what this effectively does is spin up a couple of virtual machines in various environments, such as Windows 7, Windows XP, Office 2003, Office 2010, and so on. Then we open up the file, so say it's a PDF, we open up this file, and then we observe its behavior. If this PDF was designed to have a malicious file embedded, and that malicious file was to nuke the hard drive, oh well, we don't care, because whatever happens in the virtual environment stays in the virtual environment, much like Vegas. But what we do care about is the fact that the malware exposed itself, and this gives us the intelligence to decide if it's malicious or benign. If it's malicious, we prevent this malware from entering our production network. So again, one of the threat prevention abilities and functions that we can leverage. And of course, we have app control and URL filtering, which allows us to build granular policies in the sense that meet the needs of the business today. So for example, I could build a policy that says anyone in my HR department, i.e. from the HR Active Directory group, who's accessing Facebook is allowed to, but can't do Facebook chat, Facebook post, Facebook Bejeweled, Facebook games. It effectively makes Facebook a read-only platform, which is, I guess you can see, is useful for a HR department, right? It can also differentiate between a Skype video call and a Skype file transfer. And you can have rules and policies in place that are really aligned to the business requirements. So up to this point, we know what a software-defined data center is. We know the challenges that a software-defined data center brings. We know what we need, what requirements we need, and we now know that VSEC is the manifestation of these requirements. We understand that there are two components within VSEC, a controller and a gateway. So we're going to just quickly talk about their general functions. The VSEC gateway general function is context-aware inspection. This is understanding the traffic it sees. It also provides micro-segmentation with advanced threat prevention, and also network agnostic inspection and service insertion. For example, it can insert a service that says, if a machine is being infected, let's alert the relevant teams, and let's automatically trigger a quarantine rule and some remediation action. The VSEC controller general function is to integrate with the SDN controller, in our case NSX and vCenter. Do note that we have plans to support this with ACI, Cisco's ACI, which is also an SDN controller, and then other sort of platforms like infrastructure as a service, Azure, Amazon Web Service, vCloud, and then you have OpenStack as well. But for now, we'll keep the context of VSEC within the software-defined data center realm. And with this integration, we can use cloud management objects within the checkpoint security policy. We can automatically update changes to an object in the policy, gateway, and logs in real time. So if one of the server guys build a new virtual machine, or they even change the IP address of the virtual machine, let's say they do this in NSX, VMware's NSX, because of the integration, VMware's NSX will alert checkpoint, so we'll automatically know in real time what that new IP address, what that new identity information is for that particular object within our rule base. And this does not require human intervention or a policy push. The VSEC controller also notifies the SDN controllers to mitigate or quarantine infected applications. Again, back to my previous example where we talked about tagging. Okay, remember, this is just a general high-level overview of how we secure our software-defined data center. Next week, I will be covering in-depth on how VSEC works and a more low-level detail analysis of VSEC, so tune into that. The VSEC controller also allows SDN controllers to provision VSEC gateways when needed. So let's assume we have a cluster of ESXi hosts and the server team provision 4 more new hosts. Well, the SDN controller will automatically provision VSEC gateways, and then it will alert the VSEC controller to say, hey, there's 4 more new hosts, please integrate that with your policy and push all the up-to-date stuff you need to do. Again, an automated fashion without human intervention. And then, of course, orchestrating new applications and security policy templates. Did a virtual machine change? Did it change its IP address? Is it a new virtual machine? Is it part of the web server group? All of this is orchestrated through this integration. So up to this point, in summary, software-defined data center presents some security challenges. We know that with software-defined data centers, there's an increase, an exponential increase of traffic inside a data center. This number is typically 80% of our traffic that we're currently blind to. Because we're currently blind to this traffic, which means if you can't see it, you can't control it. Therefore, there's a lack of security controls, which means there's a high vector of lateral threats. Remember my analogy about the castle? As soon as you're in the castle, it's all game over. Now we can move from application to application, from virtual machine to virtual machines within this environment. Then we talked about the dynamic changes, the way security fails, or traditional security controls fail to keep up with the dynamic changes, the day-to-day operations of a server team, from building a virtual machine, pulling it down, changing the IP address, reassigning it to another role. And then the diverse cloud environments as well. A lot of our software-defined data centers connect into infrastructure as a service, public clouds like Azure, Amazon Web Service, vCloud Air, and so on. We then talked about what's needed to address these challenges and how VSEC is the tool that we have at our disposal that effectively allows us to tackle these challenges and effectively secure the software-defined data center. And to recap, we have a perimeter security gateway. This allows checkpoint appliance to leverage advanced threat prevention for that north and southbound traffic, i.e. the traffic coming into our data center and coming out from our data center to the outside world. We then have a virtual security gateway, which lives on the hypervisor within the fabric of our software-defined data center. And we can use advanced security between virtual machines for that east and west traffic, that lateral traffic, the 80% that we're currently missing today. With the VSEC gateway, we can easily provide micro-segmentation, so we can take a flat network of many virtual machines, and with the integration we have, we can segment these out. For example, within VMware's NSX, which is their implementation of an SDN controller, they have the concept of security groups. So every time you build a virtual machine, you assign it to a group. Well, with the integration we have, we can take these groups and micro-segment all this flat network of virtual machines into those respective groups. So for example, any virtual machines in the finance security group can't talk to any virtual machines in the legal group, and so on. And of course, this is an obvious one. We have our east-west security control. We use checkpoint VSEC to control traffic access between virtual machines. So in that example, traffic from partner to legal security group must go through the checkpoint VSEC gateway so that a policy can be enforced. Because we can see the traffic, we can now prevent lateral threats by leveraging advanced threat prevention functions within the VSEC gateway. This can be IPS, antivirus, antibot, anti-spam, app control, and all of the other software blades we know and love today. And one of the key components is a unified management. We are agnostic in the sense that we don't care if it's a gateway within the fabric of the hypervisor or if it's a physical gateway. It all comes back to a single unified management system for consistent policy control and threat visibility across a virtual and perimeter gateway. And in my next week's webinar, we'll look into VSEC and how those policies look like, and you'll be blown away. You don't need multiple disparate point products. We don't need a different sort of manager altogether to manage the VSEC gateway. All comes across from a unified policy. And of course, because we're managing that traffic across the north, south, east, and westbound, we have a complete threat visibility inside the data center. So if you use Checkpoint Smart Event to monitor and investigate threats across north and south, you can now do that with the east and westbound traffic and get a complete threat visibility of the software-defined data center. With that in mind, I hope you do tune in next week where I discuss VSEC in more detail, more of a low-level drill down. It's mainly a partner-focused session. And then the week after, my colleague Don Patterson will deliver the webinar on RAT, Next Generation Security Management. I hope that has been informative for you. I'd like to thank you for watching, thank you for your time, and I hope you have a good afternoon and enjoy the rest of your weekend. Thank you.